Hi, this is Vinay, and we are going to discuss about the ICP8. So in the ICP8, we need to create a linear regression model in Python using any of the data set. So the data set I have chosen is the alcohol consumption of in USA per person in liters. So here, basically all the different kind of alcohol is basically divided into three categories: spirits, wines, and beers. So now the data that is chosen is provided by NIAAA. So for the data, we will be creating a linear regression model. Then we will see whether which line will fit into it, and we will be calculating the SSE, that is sum of square error, mean square error, as well as mean absolute error and root mean square error, y-intercept, slope, and we will explain each terminology. So the requirements here is to successfully exceeding the code with linear regression model and calculating this SSE, MSE, y-intercept, slope. So now let's move on to the code. So this is code. First step, here we are importing all the required libraries, pandas for the data analysis purpose, numpy for operation on arrays, and we'll be importing the matplot lib.pyplot from the for the graphical representation as a PLT, and then we will be importing the train test split that is used for splitting the data into training and testing from the sklearn model selection, and we will also be inputting the linear regression from sklearn.linear model to perform the linear regression. So once that we have imported all the required libraries, the next step is to upload the file. So uploading of the file, here we'll choose the file. Now I'm choosing the alcohol consumption.csv, which is a CSV file. So the file is uploaded. Now we will be converting the CSV data by using the read underscore CSV. So this is the data of 30 years. You can see here. Next, here we will be describing the data. In describe, we know that it will show us the number of count, mean, STD, standard deviation, minimum 25% of value, 50% of value, 75% of value, and maximum values. These are the three columns: spirit, beer, wine. So now let's divide the data into X and Y. So in X, I'm considering spirits and beer, and in Y, I'm considering wine. So next we need to split the data into testing and training. For the testing purpose, I'm using only 80% of testing purpose, I'm using 20%, and for training percent, I'm using 80%. So let me say this. So now the data is divided into X train, X test, Y train, and Y test. Next, we will be declaring the variable regression that stores the linear regression. Then we will evaluate the model by using the fit function. So next, we will find the slope of the X data. Here we are using the .coef underscore that contains the coefficients for the prediction of each to target. So for the X, we can see that its a slope is 0.37, and for B it's minus 0.42. So now let's find the y-intercept. So for the y-intercept, we can see that y-intercept is equal to regression dot intercept underscore. So this intercept underscore will help us in finding the y-intercept. So y-intercept for this is 2.25. Now let's predict the model. So for the prediction, we are using the X test, and predict is the keyword that we are using function. Next, we will visualize the data. So for the visualization, we are using the pandas, and we are creating a data frame with the two columns, actual and the predicted. Actual, we are using the y test, and predicted, we are using the X test. So here we can see the actual and the predicted values. These are comparatively almost same. Next, we'll plot the graph for the visualization. This is the graph that is plotted for spirits and beer, and with wine as a x-axis. So these are the consumptions in liter. So next step is to define a function which is for the sum of square. So here I am defining a function for the sum of square SSE, which has two variables, y test and predict. Next, let's evaluate the model. So here we are going to do 4 4 evaluations by using the metrics, which is mean absolute error, mean squared error, root mean square error, and square of sum of squared errors. So mean absolute error is nothing but the mean. It measures the average difference between the predicted values and actual value. Whereas coming to the MSE, it measures the average of the square of the errors. And RMSE, which is nothing but the root mean square error, which is the square root of value obtained from mean square error function. Next, we are going to perform on the SSE, that is the sum of squared errors. So for the SSE, it's measure how far our model predictions are from the observed values. So let's run this one. So here we can see that MSE is 0.06, MAE is 0.06, and MSE is 0.005, and RMSE is 0.07, and sum of square error is 0.03. Now let's create a model that has the will show the linear regression. So I'm using the feature as the spirits of NIA, target, y, and x equal to data of features dot values dot reshape. Here I'm reshaping the data with -1 and the length of the features. Next, y here I'm using the data that is nothing but the target values. Next, I'm printing the shape to see what exactly is it. Next, I'm splitting the data into x train and x test, y train and y test, and then I'm performing the linear regression and I'm fitting into it, then I'm printing it. Now let's plot a graph for this. So for the plotting, this is the plot I've used. So once this is done, here we can see the equation is y equal to 0.19x1 plus 0.7612, where a slope is 0.19, y is equal to mx plus c. So this is the formula. Next, we'll find the y-intercept. So y-intercept is the 0.7612, and the slope is equal to 0.19 and 38. And let's predict the model. So predicted model is equal to the shape of it is 6 comma, and let's visualize the data. So here in the visualization we can see the actual values and the predictor values are almost same. So this is the visualization of the, and once again I'm plotting the graph for the actual and the predicted. That means on the x it's spirits and on the y it's wine. So here we can see the blue color, it's the actual one, and sorry, the red color is the actual values and blue color is predicted values. Now let's evaluate by using these 4 parameters. So here we can see the MAE, MSE, RMSE, SSE. So these are all the 4 evaluation metrics. So we have found the slope, we have found the y-intercept, and we have also evaluated the model. So coming to the document, so these are all the formulas that are used for the MAE. For MAE, it's nothing but 1 by n, that's the average, and sigma of yi minus yi. Similarly, mean square, it's the square of the values. RMSE, we are using this formula. So that's it. Thank you.